Hello, my lovely students. Welcome back. I hope you are staying warm. It is Sunday night and oh my God, it's cold. So please try not to drive anywhere and please try not to order delivery. All right. So now we are going to take a quick dip into some statistics, talking about just basic graphs and charts, not XY graphs, just like bar graphs. And some of the ways you can organize the data for that. And then I'm going to pop into Excel and kind of play around with some of the graph making tools there. Because let's face it, if you're going to make a circle graph, you're going to use Excel or Microsoft, and it's the same thing. Okay, so first things first, though, all of those graphs that we're talking about, the data comes from a frequency table, not radio frequency, but how often something occurs frequency. So these tables are generally set up where the first column is going to be the categories of the data, so the labels or the names. And then the second column is going to list the frequency that goes with each label. So the number of times whatever is within that label shows up in our data. All right, so the first column lists the categories of data, meaning the labels. And the second column lists the frequency. Let me see what the other notes of each category. There we go. Now, second to that, these are just the raw, count them up, write that number down. Now, a lot of times though, when we're asked to show this data or explain this data or represent it, we go to the relative frequency, which is how much the frequency occurs in relation to the total. So the relative frequency is percents. Where you just take whatever the frequency was over the total. And then cumulative frequency, instead of displaying the individual frequency, each row will be the frequency of that and all previous rows added up. So a cumulative is going to get progressively larger and it will eventually add up to the total. Now, a frequency table, it doesn't have to be numbers. Like what we're going to see in our first example here is student grades on an essay, but they're letter grades, not number grades. But we can still construct a frequency chart and even do a little bit more with it. But let's start with that. So I have my handy dandy insert table button. Let's see. I'm just gonna go with, what did I just do? That's why. There we go. All righty, so A's, there are 3. Now here, hold on, let me put the headings. So these are grades, this is the frequency, and then we'll go from there. So A's, there are 3 A's. B's, there are 5 B's. Isn't it nice to type this instead of handwriting? C's. This can be a little harder to count, but 1, 2, 3, 4, 5, 6, 7. So 7 C's, And we have D's, there are 2. And F's, there are 4 folks. And that's it to making a frequency table. You come up with your labels, you come up with the frequency of each one. This is actually enough to take over to Excel and get it to make a bar chart or a pie graph. Like it'll do it just from a frequency table. But sometimes what you want to know is the relative frequency or the percentage that these occurred out of our total sample. So the sample is all the student, in this case, 20 student grades we got. Oh, good, it does. I was hoping it would expand if I typed big. All right, so for A, the relative frequency is going to be 3 out of 20, which is, of course, thank you. I love Microsoft. Most of the time I don't, but right now I'm like, yay, it did the math for me. All right, and then we are going to write that as 15%. Now this one is 5 out of 20, which is a quarter. So 0.25, so 25%. And then 7 out of 20. So this one is 35%. And then 2 out of 20 is 1/10, 0.10. So 0.1 times 100 moves it twice. So this will be 10%, not 1%. And then another 3 out of 20 gives us another 15%. All right. So if we were going to construct a pie chart, the wedge for C's would be largest, the next biggest would be B's, then the A's and the F's would tie for third biggest, and the D's would be the smallest wedge. Or we could just construct the bars of whatever height it is for the frequency. Now, cumulative frequency. First row is always going to be the same, 3. Now we have 5, but I'm going to add the previous row to that. So instead of a 5 here, I put an 8. And now I take that 8 and I add the next row 7. So now this total is 15. I take the 15 and add 2 and I get 17. I take the 17 and add 3, I get 20. So, whoa, there are the cumulative frequencies. Sometimes people use it. The nice thing is at the end, you see the total number. And if you plot this as a line graph, you can kind of see the trend as you move through the categories. It doesn't make sense for some data. It does for others. So it might be that looking at this, I see that 15 out of 20 got a passing grade. Or maybe D is my passing grade. So 17 out of 20 got a passing grade on the essay. So sometimes cumulative is nice for that if previous categories with the next categories have meaning together. That's not always the case though. If I just surveyed, what's your favorite color? Well, adding the number of people who like red and orange, like it doesn't make sense to kind of, I mean, we have a prescribed order as it were to the colors because of the rainbow, but there's not a like red is one number less than orange, which leads us into data types. So I can do a frequency chart. It doesn't have to be numbers. I can do it with letters. I can do it with colors. I can do it with favorite band, types of cars, lots of stuff. All of those kind of name labels that are categories, the fancy word for that is qualitative data. So if you ever take a statistics course, which if you do have to take another, I highly recommend statistics, but we're going to go into more of that later. So you're actually going to get it. Qualitative data is data that can't be measured on a number scale. So I can technically code some data by just assigning the numbers. So I could say red's going to be category 1, orange is going to be category 2, yellow is going to be category 3. So like they have numbers, and I could even use those numbers to plot points, but it's a numbering system I've ascribed to it. There's nothing that says I had to number in that order besides me randomly picking it. So it's not always to say if it's numbers, it's quantitative. If it's categories, it's qualitative. You have to think a little more about what are the numbers doing. So just because I force numbers doesn't mean it's quantitative. It could still be qualitative, like male, female, gender, which actually is going to get 3 now normally, or more. Those lists are getting longer and longer, as they should, but sometimes I don't know what I'm seeing. But that's me being old. All right. So qualitative data is categorical data. In fact, Alex doesn't even use the word qualitative on your homework. It just uses categorical. So it's going to give you an example and then say, is this quantitative or categorical? Which is nice because then the words aren't very similar. So if I use this, I will try to remember to put both words because I do want you to know the word qualitative, but it is very close to quantitative. So categorical data. List of more non-rankable. So non-rankable categories, I could force them into an order, but there is not an already naturally occurring order that would go on them. Now, the letters we previously did, we have this background common knowledge sense of, well, I know how A's, B's, C's, D's, and F's work. But if I was an alien, who knows? Maybe the alien thinks F is highest because it's further in our alphabet. So letter grades like that are a little peculiar. But I would not ask you letters that, if I give you grades, I mean number grades. If I give you letter grades, we're still going to treat it as more quantitative than qualitative. But the big definition here, the difference is quantitative data can be measured on a scale. So there's a low and a high end to the data. And we can rank the data, meaning organize it from lowest to highest. Assuming that things that are the same, we just list them multiple times. Now, there are some people who say it must also include a 0 value, and that gets kind of hairy. So generally the examples you have though, yeah, it's the kind of things you would measure that you're going to get a numeric answer. A lot of times what I think of here is that a decimal or an in-between number has meaning. Like take a look down here, our examples. So we're going to label these as qual or quantitative. Brand names of shoes in a consumer survey. Names, okay, that is qualitative. These are going to be labels, words. There is no way this is quantitative. So that first one is the categorical or qualitative. That quickly gets shortened to qual. So I'm just going to put that in parentheses in case I do it later. Now, our height of students. This is something I can whip out a ruler and measure, and I could say you are 5'2" or 5'2 3/4 of an inch. So I can rank the numbers, and there's in between value to those numbers. There doesn't necessarily have to be, but it's not that when I move from this step to this step, the in-between doesn't have a meaning. It just might be the in-between is not something that our data measured. Like we didn't get that exact. But height of students, very quantitative, very number crunchy. And this will often get shortened very quickly to just quant. Now this one's a little weird. So they've given us words and numbers. If it was just the words, it would be qualitative. But we can assume some ranking to the scale because it says from bad to excellent. I will say this, I will not put this on the test. And I will flog anyone who does because I know advanced statisticians who are like, well, it depends on what you're going to do with it. On the whole, though, this is more qualitative. And the reason I'm going to go with that is because 0 has no meaning on this scale. Like, what does 0 mean? Now, I might be able to rearrange the data, so maybe then 0 would have some meaning, but when they say 1 to 5 like this, it's usually deliberate. They don't want to put 0 in there. In fact, a lot of times those scales are actually like, the customer survey scales where it's like, how was your experience? 1 being bad, 2 being average, 3 being great, 4 being awesome, 5 being perfect. So like the 3 at the end are all good words. The second word was neutral and the first word was bad. That's not an equal scale. That's the kind of crap customer survey reviews will do. Also, if you do ever take one of those, unless you had a horrid experience, just hit the 5s, because a lot of people get screwed on their jobs if you don't hit the 5s. So I know it's stupid. So qualitative, because 0 has no meaning, will not put this on a test. Yuck. All right, I'm gonna pause the video here and start the next one.